Hi folks, we'll take a look at a couple of examples of using our derivative rules with exponential functions. So page 302, number 3e. So this function here, we want to find the derivative. Now we know how to find the derivative of e to the x. Here we have e to this polynomial expression, so we're going to have to use the chain rule. Okay, so again, think of this as being your intermediary u variable. So if I want to find derivative of y with respect to x, first I have to take the derivative of e to the u with respect to u, which of course we know is just e to the u. So e to the 5 minus 6x plus x squared. And then we have to multiply that by the derivative of u with respect to x. So the derivative of this polynomial. So here, derivative of 5 is 0. Here, derivative of negative 6x is just negative 6, and then plus the derivative of x squared, which is just 2x. Okay, and that's it. So we see it's the exact same procedure. We just happen to be working with this new derivative, e to the x, that we know. Okay, let's move on to 4h. So similarly here, we have a quotient of two functions, so we're going to have to use a quotient rule. Okay, so to find g prime at t, okay, first I take the derivative of the numerator. Okay, so here I'm going to have to use the chain rule. So first, again, think of 2t as being your u. So take derivative of e to the u is just e to the u. So e to the 2t times the derivative of 2t, which is 1. Then we multiply that by our denominator, 1 plus e to the 2t. Okay, then minus our numerator function, e to the 2t, times the derivative of the denominator. So derivative of 1 is 0. So again, derivative of e to the 2t, we've already taken. It's just e to the 2t times derivative of 2t, which is 2. Okay, and all that over 1 plus e to the 2t squared. Okay, now, more often than not, in a test, if I'm just asking for the derivative, I'll leave it as is. But here, let's simplify just to get a bit of practice on that. Okay, so here we have 2e to the 2t times 1 plus e to the 2t. Okay, and then here we've got 2 minus 2 times e to the 4t. Okay, over 1 plus e to the 2t squared. Okay, and if you did want to simplify further, the only thing I can really see that we can do here is to do some factoring. Okay, so if we did want to go further, you can factor out the 2, and we see that both of these terms here have an e to the 2t, so you can factor out an e to the 2t. Okay, so what are we left with? We're left with 1 plus e to the 2t from this first term, and then here we're left with an e to the 2t. Okay, and that actually works out quite nicely, because now these e to the 2t's just cancel out, as that subtraction is 0. So in the end, what are we left with for this derivative? 2e to the 2t times 1 plus e to the 2t squared. Okay, quite a bit simpler than what we started with. Okay, so I'll just pan out so that you can see both solutions. Okay, and there you have it for these two examples.